Good morning, students. Today we are going to learn the new part, that is the theorems. In the theorem, there are the first important part is the statement. By using the statement, we can write their given to prove, and for the proof of to prove, we can write their proof. So let's see first about these conditional statements and the converse. The statements which can be written in the if and they form are called conditional statements. The part of statements following if is called antecedent, and the part of following then is called consequent. For example, the diagonal of rhombus are perpendicular bisector of each other. This is the statement. The statement can be written in the conditional form as if the given quadrilateral is a rhombus, then its diagonals are perpendicular bisector of each other. It means we can write this statement in between if and then. If given quadrilateral is a rhombus, then its diagonals are perpendicular bisector of each other. Here, if the antecedent and consequent in the given condition statements are interchanged, see here, if is called antecedent, and it means given quadrilateral is a rhombus is called antecedent, and then part of then is called consequent. This is the part of antecedent and this is the part of consequent. Here the part of antecedent is a given, and in to prove the part of consequent is in to prove. Let's what is mean by converse. Converse means opposite the statement. If the antecedent and consequent in the given statement, conditional statement are interchanged, the resulting statement is called converse of given statement. If conditional statement is true, its converse is not necessary to. Study the following example. The conditional statement is, if quadrilateral is a rhombus, then its diagonals are perpendicular bisector to each other. Now, write down its converse. This is the statement. Now we can write the converse. Converse means interchange of antecedent and consequent. The converse is, if the diagonals of quadrilateral are perpendicular bisector of each other, then it is a rhombus. In this example, statements and its converse are true. Let's see here. If diagonals of quadrilateral are perpendicular to bisector, here this is a antecedent and it is a rhombus. This is a consequent. Let's see. In the statement, antecedent is a given quadrilateral is rhombus, and in the converse, consequent is it is a rhombus. In the statement, the diagonals are perpendicular bisector of each other is a consequent, and in the converse, the diagonals of quadrilateral are perpendicular bisector of each other is an antecedent. It means the interchange of antecedent and consequent is the converse. In this example, statement and its converse are true. Now let's see one more example. Suppose statement is, if a number is a prime number, then it is even or odd. And the converse is, if number is even or odd, then it is a prime number. Here, as per our rule, the statement is the number of prime number, then it is even or odd, and the converse is, if the number is even or odd, then it is a prime number. In this example, the statement is a true, but its converse is a false, because all even or odd numbers are not prime numbers, so its converse is false. Let's see the next point, proof. We have studied many properties of angles, triangles, and quadrilaterals through activities. In this standard, we are going to look at the subject of geometry with a different point of view, which was originated by a Greek mathematician Euclid, who lived in the 3rd century before Christian era. He gathered the knowledge of geometry prevailing at his time and streamlined it. He took for granted some self-evident geometrical statements which were accepted by all and called them postulates. He showed that on the basis of postulates, some more properties can be proved logically. The properties proved logically are called theorems. Some Euclid postulates are given below. The first is, there are infinite lines passing through a point. It means here, suppose this is a one point, so there are infinite lines can passing through the one point. The second postulate is, there is one and only line can passing through two distinct points. Here these 2 points are different, so here only one line can pass through the two different points. The circle of given radius can be drawn taking any point at its center. The fourth postulate is, all right angles are congruent with each other. Fifth postulates, the two interior angles formed on one side of a transversal of two lines add up to less than two right angles, then the line produced that direction intersect each other. We have verified some of these postulates through the activity. The property is supposed to be true if it can be proved logically. It is then called the theorem, and the logically argument made the proof. A theorem is called proof. When we are going to prove that conditional statement is true, its antecedent is a called given part and the consequent is called part to be proved. Here antecedent is a given and consequent part is to prove. There are two types of proofs, direct and indirect. Let us give a direct proof of property of angle made by two intersecting lines. Let's see the theorem first. We'll see here direct proof. Let's see here theorem. The opposite angle formed by two intersecting lines are of equal measures. This is a statement. The opposite angle formed by two intersecting lines are of equal measures. In this statement, the given part means antecedent is the opposite angle formed by two intersecting lines. So first draw here figure. These two lines are AB and CD. That lines are intersecting at point O. So write in given line AB and line CD intersect at point O such that A-O-B and C-O-T, it means AOB and COD. These are the collinear points. AOB is collinear, COD is collinear, O point is between A and B and C and D. Now to prove means which statement here we have to prove, that is a consequent part. Then that angles are equal measures. So first find out here angle AOD congruent angle COB. So to prove is the first proof angle AOC congruent angle BOD, and the second this opposite angle means angle angle AOD congruent angle COB. We have to prove these two angles are equal. This is the to prove, because we have to prove these opposite angles are equal in measures. Let's write down proof. Proof means a property is supposed to be true if it can be proved logically. This is called a theorem, and the logical argument made to prove a theorem is called a proof. Let's see first here angle AOC plus angle BOC is equal to 180 degree. AOC and BOC. These two angles are, this is your statement number 1, and reason is linear pair angle. In proof, each step want a reason. Without reason, you can't written here any statement. The second one, angle BOD plus angle BOC is equal to 180 degree. See this angle BOD plus angle BOC. These two angles are also linear pair angle. Now from statement 1 and 2, their RHS, it means 180 degree, is equal. So therefore angle AOC plus angle BOC is equal to angle BOD plus angle BOC, because in these two statements their RHS is equal. So LHS is also equal, means left hand side. RHS means right hand side. So angle AOC plus angle BOC is equal to angle BOD plus angle BOC. Here the reason is from 1 and 2. Here angle plus BOC and plus BOC get cancelled because this plus become minus and it will get cancelled. So therefore angle AOC is equal to angle BOD. Hence proof. Let's see here second statement. Again write down like this. Angle AOD plus angle AOC is equal to 180 degree. See this. Angle AOD and angle AOC. These two angles are sum of these two angles are 180 degree because these two angles are linear pair and linear pair angles are supplementary. This is statement number 1. The reason is linear pair angle and angle AOC plus angle BOC plus angle COP is equal to 180 degree. Statement number 2. This is also linear pair angle. AOC and COB. These two are the linear pair angles and linear pair angles are the supplementary. So here from 1 and 2 RHS is equal, then LHS are also equal. So angle AOD plus angle AOC is equal to angle AOC plus angle COP. The reason is from, we given here 1 and 2, so write here 3 and 4. From 3 and 4. Then here angle AOC get cancelled. Therefore angle AOD equal to angle COB. Hence proof. So here to prove is we prove this logically. So this is the proof, to proof and the given. In between the part if and then is given. After the part then, that is to prove, and the logically proof is a proof. See this theorem. Okay, complete. first we have seen the direct proof. Now we are going to see the indirect proof. See on the screen, this type of proof starts with the assumption that is a consequence is a false. Using it, the property accepted earlier. We start arguing step by step and reach the conclusion. The conclusion is contradictory with an antecedent or a property which is already accepted. Hence, the assumption that the consequent is a false goes wrong. So, it is accepted that the consequent is a true. Let's see the example. The statement is a prime number greater than 2 is odd. The conditional statement is if p is a prime number greater than 2, then it is a odd. It means the statement is a prime number greater than 2 is odd by using if and then form. If p is a prime number greater than 2, then it is a odd. So in given, between if and then, that part is in given. P is a prime number greater than 2, that is 1 and p are the only divisor of p. In 2 prove, the part after the then, it is odd. So in 2 prove, p is an odd number. Now let's prove. Let us suppose that p is not an odd number. So p is an even number. Therefore, a divisor of p is a 2 because this is an even number. Even number means what? All even numbers are divisible by 2. So, a divisor of p is a 2. This is your statement number 1. But it is given that p is a prime number greater than 2. This statement is written in the given. So, reason is given. Therefore, 1 and p are the only divisor of p. This is your statement number 2. The statement 1 and 2 are contradictory. See, our statement 1 is a divisor of p is 2 and statement number 2 is 1 and p are only divisor of p. So first and second statements are contradictory. So therefore our assumption that is p is not odd is false. If our assumption is false, therefore this proof proves that the prime number greater than 2 is odd. This is the indirect proof. here our chapter 1 is over. Let's see the practice set 1.3. There are two questions. The first question is, write the following statement in if and then form. There are three statements. For example, the opposite angle of parallelogram are common. This statement you can written in if and then form. If given quadrilateral is parallelogram, then their opposite angles are congruent. Like this, you can write these three statements in if and then form. The question number 2, write the converse of following statement. For example, the first is, if alternate angle formed by two parallel lines and their transversals are congruent, and their converse is if alternate angle made by two lines and its transversals are congruent, then lines are parallel. So like this you can solve here practice set 1.3. Here our practice set is. Here our chapter is over. Tomorrow your homework is practice set 1.3. Tomorrow we are going to discuss on problem set 1. Okay. Thank you and have a nice day.